Hello and welcome to yet another lecture on control system. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. Today we will discuss the signal flow graph approach or technique. Generally, we will concentrate on the Mason's gain formula in order to find the transfer function of a system. Signal flow graph is one of the easiest approach in order to find the transfer function of a particular system. So, the general conception of a transfer function is known to us, that is, the transfer function can be written as the Laplace output to the Laplace input, keeping all the initial conditions at 0. So, the transfer function can be written as output by input, output by input in Laplace domain or S domain, in Laplace domain or S domain, in all the initial conditions equal to 0. So today, this is the equation of the transfer function. So today we will concentrate on a signal flow graph SFG conception. This is known as signal flow graph. In order to find the transfer function of the system. So generally what we have used the Mason's gain formula. So according to the Mason's gain formula, the transfer function can be written as summation over Pi del I from the value of I equal to 1 to n divided by the del. So where n is the total number of forward paths and Pi is the ith forward path gain. And what is the del I? Del I is the value of del after eliminating the loop gains that are touching the ith forward path. And del is the 1 minus all the summation of all the individual loop gains plus summation of gain product of all the possible combination of two non-touching loops minus summation of all the three non-touching loops plus summation of both non-touching loops. This is the general equation of Mason's gain formula in order to find the transfer function. So it is written as transfer function can be calculated summation over from I equals to 1 to n. It is written that I equal to 1 to n pi del I pi del I divided by del. This is the general equation of Mason's gain formula in order to find the transfer function of a system. So let us approach to a model a problem in order to find the transfer function using Mason's gain formula. So for this example, we are not trying to do this particular example. So it is given that we have to find the transfer function using the conception of Mason gain formula on that particular. First, how we can able to apply this. So, so we just concentrate on the problem, then we approach to the solution using the conception of Newton's scale form. Is G1, so that the gains are given G2, G3, G3, and this is value is 1. This is the general formula in order to, so I can write it in a, so 1, this is G1, so that can be easily understood. This is the gain for this part G2, for this part G3, for this part system. These are generally known as the nodes. These are known as nodes. And again, that is given as G4. One is given as minus H1. This is given as minus H1. So we have to find the transfer function. We have to find the transfer function is the conception of Mason's gain formula. So let us concentrate on, first we will concentrate on the forward path. So according to the Mason gains formula, first we have to calculate the number of forward paths. So forward path means from the starting, means from that point we have to reach that point. From that point we have to reach that point. This is called the in a forward direction mode of the game, depending on the direction. So we have seen that this is, we have two forward paths. One is this, and another is this one. And another forward path is this one. From the final point to the destination point. So there are a number of forward paths that we can retain n equal to total number of forward paths equal to 2. Now, the gain at the first forward path, that is Pi, that is we have known. So that is P1, the gain that is given in the green color. It is 1 into G1 into G2 into G3 into 1 it is the gain of the first forward path G1, G2 and G3. It is the gain of the first forward path. Now we will concentrate on the second forward path. So what is the gain that is called the P2 of the second forward path? It is given 1 into G4 into 1, that is G4. That is the gain of the second forward path. It is given by G4. So now we have to concentrate on the loop. So what does loop means? Loop means that Say a graph is starting from a particular node and it is returning back to that node. This is called a loop. This is the definition of a loop because this is a node, this is a node. So if it started from a particular node and it is come back to that node, this is called a loop. So here, in order to find the loop, so this is a one node and the graph is starting from here, just going through the direction. Direction will indicate the node. The direction is given that it is coming back to that particular node. So this is one I can write as a loop one. So what is the gain of the loop one? The gain of the loop one is G1 into G2 into minus H1. It is minus G1 G2 into H1. What is the another loop? The another loop that I have found is that starting from that particular node, it is going in that direction and it is coming back. Just follow the direction, coming back to that node. So this is another loop. It is first loop is drawn with the red color and the second loop is drawn with the blue color and it is minus G2 G3 into H2. So this is the second loop that we have found. So if we have already seen the forward part, we have already seen the loops. So what is the value of del? Del that we have known that del is 1 minus all the individual loop gains plus gain product of all possible combination of two non-touching loops minus 3 summation of 3 non-touching loops for summation of 4 non-touching loops. So in order to find the value of del, so it is given that del equal to 1 minus all the loop gains, that is L1 plus L2 plus two non-touching loops. There are number of loops is 2. So the both loops are touching because is here there's a loop of touching. Touching loop means there's a common node between the two loops. Say this is a loop and say this is another loop. So both loop are touching means there is a common node between the two loops. So here we are also seeing that there is a common node between the two loops, that is the this node. So that is why these two loops are touching and it is clearly seen. So if there is only two loops and that those two loops are non-touching, are touching, so there is a no question of gain product, summation of gain product of all the combination of two non-touching loops. So the del value will be this one. So what is the value of del 1? Del 1 means that is the del I that is given, that value of del means this value of that del after eliminating the loop gains that are touching in the ith forward path. Means first for del I, it is the value of del after eliminating all the loop gains that is touching in the first forward path. So if I saw the graph, it is seen that this is the first forward path. It is denoted in the green color, and that both two loops are connected, touched, are or connected in the first forward path, means they are in touch with the first forward path, means all the combinations of those two loops must be minused from the del in order to find the del 1. So means if I have minus the L1 and L2 from del 1 from del in order to find the del 1, that del 1 will be 1. Del 1 means all the possible combinations of the loop gains that is touching the first forward path must be minus or must be touching the first ith forward path after eliminating all the loop gains. Means all the loop gains are minus from the, also subtracted from the del value. So if I minus all the loop gains, so it is remain only 1 because both two loops are touched in the ith forward path. So what is the del 2? Del 2 means that value of del after eliminating all the loop gains, that is the second forward path. So second forward path is denoted by the yellow color. So both two loops are touching, are in touch with the second forward path. This loop is touched here and this loop is touched here. The loop that is denoted by the red color is touched at that particular node, and this loop which is denoted by the blue color is touched at that particular node for the second forward pass that is denoted by the yellow color. So means all the loop gains is nullified, so the del value is 1. So what is the transfer function? The transfer function is that we have found is that transfer function can be found with the help of summation over I equal to 1 to n, means I equal, there are two forward paths, so 1 to 2, that's p1 del 1 plus p2 del 2. So the transfer function that is found, that is p1 del 1 plus p2 del 2 divided by the del. So the del 1 and del 2 are 1. So p1 will be written as, the entire transfer function can be written as p1 means g1, g2, g3 into 1 for the del 1. p2 is g4 followed by 1 minus del. Del is 1 minus L1 L2. So 1 minus of L1 means plus G1, G2, H1 plus G2 is the plus L2, G2, G3 and the H2. So this is the transfer function that we have obtained from the signal flow graph approach. We are using the conception of SFG, the signal flow graph, and we have found the transfer function. The transfer function value is this one. That is G1, G2, G3 plus G4 by 1 plus G1, G2, H1 plus G2, G3, H2. This is the help of an SFG, the signal flow graph approach. We can easily find the transfer function of a signal. So let us take this block diagram. So if I converted this block diagram, an electrical circuit into an equivalent S domain circuit, it is found that it will be L will be SL, C will be 1 by SC, and this is the R2, and the voltage across this is V0, and the input voltage is V1, Vi or V1, current is Is. Because so the equivalent, electrical equivalent of that circuit, the circuit that is here is that we have to go through the SFG approach in order to find the Laplace transformation of, in order to find the transfer function of that particular circuit. That is R1, that is L, R2, C. VG. So in order to convert this into a Laplace circuit, that I2 will become IS, V0 became V0S, Vi became VIS, L became SL, and C became 1 by S. That is, I am converting it from uh, from a time domain to a Laplace domain. So what is the value of IS? First, we will concentrate the value of the IS. IS is the voltage difference between that two points, that is V1 is that point and that point, that is V1 is minus V0 is minus V0 is, it is divided by R1 plus SL. That is the IS. And what is the V0 is? V0 is can be written as IS into R2 plus 1 by SC. Now putting that V0 is value in that equation number, it's called the equation number 1. This is called the equation number 2. So putting the equation 2 as the V0 value in equation number 1, so we are getting IS equal to 1 by R1 SL plus putting the equation 2 to equation number 1, V1 is plus minus of 1 by, means we are just we are not putting the equation 2 to equation 1, we are just simplify the equation, rather than make it simplify, we are not putting the equation 2 to equation 1, we are just making a simplified form to draw the graph, that is V0. Yes. So now we will concentrate on how we can draw the SFG, the signal flow graph. So how we can draw the SFG. So in order to draw the SFG, first of all, how many nodes we have to consider? So there are three nodes that I have considered because there are three variables. One is the V0, one is the Vi. Three electrical quantities, three variables are there, means V1 and one is the I. Yes, I. So that is why I am taking, there is a yes, three nodes in order to draw the SFG. So this is called the node A, and it is written as V1. This is called the node 2 that I am writing. Let's say this is our node 3. And last one is the V0 and the node, this one is the I. So I am written that. Okay. So now I am concentrating on first. So what is the, in order to first going through that these details, that V0 is equal to Is into R2 plus 1 by SC. So here we can write and gain straight away I0 is multiplying with R2, IS is multiplying with R2 plus 1 by SC to find the V0 from that equation 2. Now from that equation 3, you can find that what is the IS? IS is that V0 is multiplying with minus 1 by R1 plus SL. So I am taking a feedback, that is minus 1 by R1 plus SL. And with V1 it is multiplying with a factor called 1 by R1 plus SL in order to find the total signal flow graph. First we have to consider how many nodes are there, because graph is totally dependent on the nodes. So number of variables are number of nodes. So that we have easily find the value of the signal flow approach. So let us concentrate from the graph that what is the forward path. There is only one forward path is there. So the gain at the forward path is 1 by R1 plus SL into R2 by SC. N is 1. So what is the loop? Loop is 1, that is seen here, and the gain of the loop is given that R2 plus 1 by SC, that is R2 plus, what is the gain loop? R2 plus 1 by SC into minus 1 by R1 plus SL. And this is the only one forward path is there in this. This is only one forward path, and this is the only one loop is there. This is the loop. So the gain of the loop and the forward path that I have calculated here, it is loop is from that loop is R2 plus 1 by SC into minus 1 by R1 plus SL. So if I put the values of the transfer function there, so the first one, the forward path, that is from V1 to V0 that I have reached, only one unidirectional, and is to find the forward path, and it is 1 by R1 plus SL into R2 by 1 by SC, and the loop is that is given is R2 by 1 by SC into minus 1 by R1 plus SL. So to find the transfer function, just put the Mason gains formula, and we will find that the transfer function can be written in the term of Cs plus D divided by S square plus As plus D. So highest power of the A is that is denoted by the S square, and it is a second order system that found the highest power of the S. So it will given, just putting the Mason's Games formula, P1 del 1 divided by the del. So it will found that the transfer function will be just calculating that particular part, just putting those values, and we will find the transfer function can be in the form of Cs plus D divided by S square plus As plus B, that S square, that is the, get the highest power of the S at denominator will give the second order system. So today we have learned about Mason Gaines formula. There is a signal flow graph, and how easily we can find the transfer function with the help of the signal flow graph, in order so that we can easily find the transfer function with the help of signal flow graph, and also how we can easily reduce electrical circuit to a signal flow graph in order to find the transfer function of that electrical circuit. Thank you.